So this story was broken this week on the 17th on Twitter by Hector Martin, as you can see it on screen right now. So everyone listening on this to this on audio format later on, you can get the link to the Twitter thread in the show notes. For everyone who is on stream, I will quickly post the show notes again, so you can get to the links if you want to see the articles yourself. So yeah, so they made some testing in regards to the SSDs in current generation Macs. So the M series Apple Silicon chips, as well as the older systems that were running the SSDs through the T2 security chip. And it seems like they found some interesting behavior of macOS, and that is not boasting really well in terms of data integrity for the current generations of Macs. So there is a mechanism to flush data to disk on Linux, as you can see here in the first reply post. There is a command called fsync that basically flushes all the data to disk, and yeah, that seems not to be properly implemented or implemented in the same way on Macs. So as he writes here, as it turns out, macOS cheats. On Linux, fsync will both flush writes to the drive and ask it to flush its write cache to stable storage. But on macOS, fsync only flushes writes to the drive. Instead, they provide an full sync operation to do what fsync does on Linux. And they continue. So effectively, macOS cheats on benchmarks. FIO on macOS does not give numbers comparable to Linux, and databases and other applications requiring data integrity on macOS need to special case it and use full sync. So the question is, how bad is it? And they provide some benchmarks here. So single-threaded, simple Python file write test on a MacBook Air M1 on macOS. Flushing gives you 46 IOPS. Not flushing gives you 40,000 IOPS. On a x86 iMac, so with the T2 chip, and a Western Digital SN550 NVMe SSD with 1 terabyte capacity, you're getting 20,000 IOPS when flushing, and 2,000 IOPS when flushing, and 20,000 when you're actually not flushing with fsync. And when you compare that to a x86 laptop with a Samsung 860 Evo, so which is a SATA SSD, you're getting 143 IOPS when flushing and 5,000 when not. So the M1 chip in a MacBook Air is actually slower than it's actually slower than a SATA SSD. Bribery Drury in chat asks, what is IOPS? Basically, IOPS is the number of operations a drive does per second. So let's say you're reading and writing data. Each read and write operation is one operation, and all these operations combined per second determine the IOPS basically. So input output operation as input operations per second. Okay. Okay, that is interesting. I don't know why Moobot is posting that now in chat, because that should only pop up in VR streams. But nevertheless. So I hope that answers the question, Barry. Yeah, so that means that if the applications in macOS are not using those particular additional commands that are not common to other Unix systems, so they have to use this F full sync operation in order to get the same result on macOS, which of course will heavily impact performance. This will be problematic if for some reason when you are using a desktop Mac and you have a power outage, or even with a notebook, or when the system crashes, or there are several issues that you can have with a scenario like that. And yeah, that's a real problem. So I don't know how is it with the newer M1 chips, but I presume that the issue is the same. Let me quickly check this, if they have something in here about the bigger models, but that doesn't look like it. I actually don't know why they put all this reporting into a Twitter thread. That would be much better to put everything into a Medium article if you don't run your own blog. So yeah, but this is definitely a situation I hope that Apple will A, respond to, and B, resolve it in the upcoming Macs. So we are rumored to get the first Macs with the updated M2 chip this year. So new MacBook Air, Mac Mini. Yeah, so that was the Apple topic.